Hello, welcome back to another episode of Solving LEETCODE Hard Question. Today's question is permutation sequence. The question is as follows. The set 1, 2, 3 all the way to n contains a total of n factorial unique permutations. For example, by listing and labeling all of the permutations in order, we get the following sequence for n equals to 3. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Given n and k, return the kth permutation sequence. In the example above, where n equals to 3 and k equals to 3, we will return the third number, which is 2, 1, 3. The second example is when n equals to 4 and k equals to 9, and the answer is 2, 3, 1, 4. We'll use this as an example as we solve this problem. We also have the convenient constraint that n is between 1 to 9 and k is between 1 to n factorial. So the index is always in range. How do we solve this? Pause here if you'd like to think independently for a moment. Let's look at the example where n equals to 4 and k equals to 9. There are 4 factorial, which is 4 times 3 times 2 times 1 equals to 24 possibilities. If we look at the sequence closely, we'll notice that the first 6 numbers all start with 1, and the next set of 6 numbers all start with 2, then 3, then 4. The second number will change every 2 times. Then the remaining numbers just alternate each time. Do you see the pattern here? To summarize, we observe that the number at each index would change every I factorial times. Well, this is because if we were to pick one number at the first spot, this leaves 3 factorial possibilities for the rest of the 3 numbers. Similarly, if we already picked the first 2 numbers, this will leave 2 factorial possibilities for the remaining 2 numbers. To calculate the number at each index, we can integer divide the remainder of k by the changing frequency. Since in the division and modulo world, index starts at 0, we'll subtract k by 1 first. The numbers we can choose from are 1, 2, 3, and 4. To choose the first spot, we'll calculate 8 integer divided by 6, which is 1, which means we'll choose the second number, and that is 2. And now k is reduced to 8 modulo 6, which is 2. Since we've chosen 2, 2 is no longer an option for our next choice. It's between 1, 3, and 4 now. We'll repeat the same calculation. 2 integer divided by 2 is equal to 1, which means we'll choose the second number again. And the second number in the remaining list is 3. So 3 is chosen. 2 modulo 2 is 0. This means that the rest of the numbers can be added in order. And that is how we arrive at our final answer. This is the Python code of what we just did. First, we'll build the permutation array to tell us how often each spot changes. Then we'll subtract k by 1 to adjust the index. And we initialize a nums array to represent the choices of numbers we have. While k is greater than 0, we can calculate which number to choose from nums by integer dividing k by the changing frequency. This would give us the index from nums that we can choose to add to our result. And we need to reduce k accordingly and remove the number from the nums array so they can no longer be considered in the next iteration. When k reaches 0, that means the remaining numbers can be added in order. The final time complexity is O of n if removing from the list is O of 1. And the final space complexity is also O of n. Did you get it? Let me know if you have any questions in the comments, and thank you for watching.